Right, I want to take us back to 1887 when two gentlemen called Michelson and Morley did an experiment to prove the non-existence of something that was known as the luminiferous ether. And what the luminiferous ether was a hypothetical substance that filled space. And the reason they'd come up with this hypothesis was because they simply could not understand how electromagnetic radiation, i.e. light and heat and everything else, could get from the sun to the earth, because space is a vacuum. And as you know, when something is a wave, it's a wave in another medium. So you need something to wave in order for waves to get from the sun to the earth. And what they wanted to do, they came up with this hypothetical idea of something called the luminiferous ether, which literally means light carrying, luminiferous. And what they did was they did an experiment to actually test it. When I won't go into the details of the experiment, what they proved is that the luminiferous ether did not exist, which is extraordinary in itself, because suddenly there was a massive problem. Because how could waves get from the sun to the earth? What was waving? Now, what is fascinating is that in 1894, Albert Michelson, was asked to give a talk on the opening of the Ryerson laboratory at the University of Chicago. And he made this fascinating speech and talk. And he was very precise, and he said, in terms of physics, we know so much about what the world is made of now, that physicists for the future will only be calculating to the 6th decimal point. He was so sure that they knew everything. And I think I'm right in saying that he paraphrased an English physicist called Jeans, who had actually said that there are only one or two dark issues with science. And one of the dark issues of science at the time was something called the mystery of black body radiation. And also, of course, one of the mysteries was how waves crossed space. Now, he was so sure he was right. But there were the mysteries, there were the white crows, the black swans, the things, the outliers within science that don't make sense. And it's in those areas that science evolves. It doesn't move on by looking at the same things over and over again. It looks at the outliers, the things that don't make sense, that means that your model of the universe is not fully correct. Now, for instance, within modern science, we still have this problem. For instance, we have two areas of science. We have the things that deal with the very big, which is effectively relativity, Einsteinian relativity. And then we have the things that deal with the very, very small, quantum mechanics. But within the maths of these two things, there's a huge problem. Because if you use the maths that they apply to one, if you apply it to the other, you get infinities, you get really strange and curious setups. So clearly, whatever our understanding of reality is, there's a deeper level that we haven't even scratched yet. Now, students of history will know that there have been many, many scientific revolutions throughout the centuries. There was the Thomas Kuhn theory of the science of scientific revolutions, and the idea that the medieval schoolmen had models of understanding of how the universe worked, which worked with certain outliers. Like one of the major outliers that they had at that time was the retrograde motion of the outer planets, because they believed that the Earth was the centre of the solar system and everything rolled around it. But there were certain movements within the sky that made no sense. So they create these things called epicycles to make it work. And the science became more and more turgid, more and more complex, and more weird, which is what we have now with quantum mechanics. Because within quantum mechanics, clearly there's an awful lot in quantum mechanics that makes absolutely no sense. And as Richard Feynman, one of the world's greatest quantum physicists of the last century, turned around and said to his students when they were talking about doing a course on quantum mechanics, he turned around and said, don't try to even begin to understand why the things are the way they are, it's just the way they are. Now, my argument is, we've got to start thinking again about this. Let's not stand around in a state of hubris, pretending that we understand everything, when we know that 94% of the universe is missing. 94% of there's only 6% of the universe which is known as baryonic matter, which is the physical things that surround us. But 94% is missing. The rest is made up of dark energy and what is jokingly called dark matter. And the only reason they're called dark matter and dark energy is nobody has a clue what they are. So here we are standing around saying, oh, we know everything there is to know about science, yet we don't know anything. For instance, we think everything that's physically real. You know, this table here, you knock this table, it's 99.999999999996 empty space. And what's inside it are actual point particles that have no extension in space. So suddenly the whole reasoning about the way the world works is stranger than we can ever imagine. Now, we all know from our history that in 1900, a certain gentleman called Max Planck stood up in December of 1900 in Berlin and made a statement about the nature of energy. And he got over the problems, a number of the problems that Michelson had actually mentioned. And he did so by saying that energy comes in little packages or quanta. And that's where the word quantum mechanics comes from. Quanta is just Latin for package. And he argued that energy is not continual, it's in little chunks, which are separate from each other. And he turned around and he said this was an act of desperation, because he had no other way to make it work. And funnily enough, he was actually doing this exercise to make electric lights work more effectively, because the Germans felt they were being left behind by the Americans and the British. So they decided that they would find ways of making electric lights more interesting. 1904, Albert Einstein comes along and explains many things, including the problem of the luminiferous ether and something called the photoelectric effect, where he turned around and said, well, let's not assume that light is a wave, let's imagine it's little tiny point particles. And a little point particle can travel through a vacuum. And suddenly that was solved. But many other problems were raised from that, because of course we know that light still seems to be like a wave and like a particle. So that all these interesting things. But it seems to me that Michelson had an issue about one major area, and it's an area that each person in this room knows is true. Self-referential consciousness. You are all sentient beings listening to my ramblings here. There is something inside your head looking out at the reality around you. There's something that's processing the information. There's something that's thinking about the implications of what I'm saying. Science cannot explain this. In the mid-1990s, a young Australian philosopher called David Chalmers stood up at the University of Arizona and stated that science, there's the hard problem, the soft problem of science, which is how the brain works, and there's the hard problem of science, which is how inanimate matter, i.e. molecules and atoms reacting in electrical fields, creates consciousness, which are two completely different things, aren't they? Consciousness is not physical, but it's supposedly created by the interaction of chemicals. So what you are really when you're sitting here listening to my words are just chemicals reacting with each other. Now that does not make sense. And one of the major areas I think that we need to start addressing is what happens to human consciousness when we die. The near-death experience, what is really going on here? Now you will have dozens of books in shops like this which will discuss near-death experiences. But all it will be a series of anecdotes. It will be, it happened to me. Joe Bloggs died and he floated out of his body and he saw Jesus and he met his great aunt and everything else as well. But that's all they are, a series of anecdotes. And as one famous philosopher once said, the plural of anecdote is not proof. You can have anecdotes all the time, but you need to do the science. And I'm one of those rare animals that's trying to do the science of the near-death experience. If you read my books, you will know I will do the science first. And I'm particularly fascinated by the neurological aspects of the near-death experience. What is really taking place in the brain. And the interesting irony here, and I love synchronicities, is that in 100 years after Michelson made his famous statement, there was a discovery made using what is, and I need to get this correct, is bispectral index monitoring, which is what happens is when somebody is being operated upon, the doctors and the surgeons need to know that you're not conscious. So what they do is they have these electrodes that they place on the surface of the head, and it measures brain activity. And when they know that the brain activity falls to a certain level, they know the person is unconscious, which means they won't feel pain and they can do the operation. Profoundly important. But people started working with these things, and they found something strange. And there was an event that took place in 2008 when there was a 79-year-old lady who, while she was under one of these analyses, she died. But they were astonished to discover that her brain activity didn't stop after she died. It continued. The brain continued firing up. It continued with things happening in her brain. And this really quite fascinated researchers. And there was something created a few years later called a SED line, SED line. And this is a more sophisticated version of the other monitoring. And the difference with the SED line is that it can not only measure what's going on in the brain, but it can record it. So suddenly scientists had an ability to not only measure what was happening at the point of death, but record it. So they would have a track, so they would know what was taking place. And a series of very interesting experiments took place on this. And in 2009, there was a gentleman called Lakshmi Chawla. And Chawla was a neurosurgeon working, I think, in Washington State. And he did some research on dying people. And they were able to measure the brain activity of dying people. And much to their astonishment, they found that the brain, again, seems to, as death approaches, seems to suddenly go into a massive amount of activity. Specifically, gamma wave activity in the brain. Now, gamma waves are very interesting. There are different kinds of brain waves. And gamma brain waves are the ones that show that brain activity is really taking place. Like, for instance, neurologists will know that if you scan the brain of somebody with an EEG when they are dreaming, the gamma ray activity normally is bigger and greater. And I know of an experiment which I don't quote in the book, but is a very interesting one, where there was a guy that was having his brain scanned for an experiment while he was sleeping. And while he was sleeping, he dreamt that he was playing tennis. So they had a trace of what happens in the brain when somebody is playing tennis. When he came to and everything else, they thought, this is really quite interesting. I wonder what would happen in the brain when he's really playing tennis. And much to their astonishment, they found that exactly the same parts of the brain lit up when he was dreaming of playing tennis to when he was actually playing tennis. Now, this is extraordinary, because it means that when you're dreaming about running down, being chased by a monster, or when you're dreaming of meeting loved ones, the same areas of your brain are firing up as if you were doing it in reality. Now, surely, if dreams are just confabulations, surely different parts of the brain would light up. It would be a different kind of thing, but it's not. It's exactly the same. So when people turn around and say that three-dimensional reality that we perceive is real and out there, whereas if you dream of that three-dimensional reality, that's an hallucination, suddenly we've got something that's much more interesting going on. And indeed, such was the work that they continued doing some work on this. And back in 2014, I think it was, there was a lady called Jimo Borjigin at the University of Michigan. And they did a series of experiments where they euthanized rats. They wanted to know about how humane it would be using rats in circumstances, in experiments and everything else as well. So what they did was they had a group of rats, and they measured the brain activity using something subtly different from the SED line. What they used there was they actually placed electrodes into the brains of the rats, because they were able to do it, because they didn't, like a normal human being, you can't do that, whereas they knew that the rat was going to die. So they placed the electrodes into more of the centre of the brain to see what happened. And they measured the brain activity when the rats were fully active. then when they were under anaesthetic, and then when they were dead. Which is very interesting. But what they discovered is absolutely unbelievable. Not known across the world. I have no idea. The only reason I can think is because it's almost forbidden knowledge. They don't want people to know about this, because if they did know about it, they'd be thinking differently about the world. They discovered that up to 180 seconds after the rat had been killed, the brain suddenly goes poof and starts activity again. Gamma wave activity. Which means effectively a dead rat or a dead rat's brain is dreaming. But it's dead. And it's not the argument that, what we mean by death. And in my new book I have a whole section on the arguments of what we mean when somebody's dead, what we mean legally, what we mean physiologically, what we mean neurologically. These rats were brain dead. There was no supposed brain activity taking place, and yet the brain suddenly kicked off. And it wasn't just with these rats. They repeated the experiments, and they happened a number of occasions. So the question was asked, well, what is going on in a rat's brain when that happens? Which is all very intriguing, but a rat's brain is a rat's brain, it's not a human brain. But then something extraordinary happened, and I just need to get my, just to go back a little bit as well. In 2018 as well, there was a guy called Pierpaolo Pani, an Italian researcher. And he was using, again, brain monitoring scanners for, and there was a macaque monkey, which they then euthanized. His brain kept recording and kept active for hours afterwards. The brain, for hours afterwards, it was still active. So again, we suddenly find these things are really strange. But the difficulty was, how can you ever do this with a real human being? You can't just euthanize a human being to find out what happens in the brain, because that's murder. But fortuitously, what happened back in 2022 was a really curious event took place. There was an American guy living in Germany in his late 80s, and he fell off a ladder, and he damaged himself and everything else as well, and he was rushed to hospital, and they brought him to and everything. But then they decided they wanted to put him in a brain scanner, EEG scanner, to just test his brain activity. And while he was in this state, he died. And guess what? Exactly the same thing happened. For the first time, there had been a measurement of a person's brain activity as they died, and immediately afterwards. So yet again, we have the issue of brain activity and dreaming after the person has died. So this question has to be then, well, what do we really mean, and what are we really discovering here? And I'd like to argue that what is really taking place is they are measuring the actual near-death experience. For the first time ever, near-death experiences have now been measured using scientific equipment. Now this is intriguing, and if you read the press on this, or you read the academic papers, because you won't find a lot of this in the press, and in my book I give you all the academic papers. In fact, for the research of this book, I read virtually every single academic paper that's been written on the near-death experience for the last 50 years. So within this book is real science, the arguments, the negotiations and everything else that took place. So the argument was, right, science had proven that the near-death experience is an hallucination. Well done, boys. The near-death experience is nothing other than an hallucination. So we've solved it. Breaking news, guys. You haven't solved it, you've given it a label. You've said it's an hallucination. But nobody knows what an hallucination is. We don't know what is perceiving the hallucination, let alone what an hallucination is. We know that the reality we see now is an hallucination. In fact, you're probably aware that individuals that believe that there's a one-to-one relationship between what you're perceiving and what your brain presents to you is as it is, are called naive realists. And they have been called naive realists by scientists for generations. Because scientists know that what the brain presents to you is only a facsimile of what is out there. And a moment's reflection will tell you that it's only a facsimile. The world changes when you're drunk. The world changes when you take psychedelics. How does this happen? How does it happen that I can take dimethyltryptamine and my whole worldview changes? I go into a completely different universe, a different place, that seems, from the people I know that have experienced these things, tell me that the reality they go to when they're taking DMT is actually far more real than this one. And the feeling is when you take DMT, you come back to this reality going, wow, this is not the real one, this is the dream. So the question then is, well, what really do we mean by perception? What do we mean when we say that there is an out there and an in there? We know, as I mentioned before, that everything you're perceiving out here is empty space, mostly. The only reason that my finger doesn't go through that table is something called electrostatic repulsion. At the end of each of the atoms in that table are electrons in the outer shell. And each electron is negatively charged. And in the end of my finger, there are also atoms that have an electron going at the outer shell, which is negatively charged. So you remember, as your school day physics, two negatives repulse. And that's exactly what's taking place. You never touch anything, ever. And that is a profoundly important point. So the reason that, even though that is what I said, 99.9 or whatever empty space, you don't go through it because of electrostatic repulsion. So you never actually touch the real world, but you never actually see it either. What takes place is tiny little things called photons, which we were talking about before, that Einstein theoretically discovered but didn't name. Somebody else named them photons. These little tiny point particles that can be a wave or a particle depending upon how they're measured or how they're observed, because there's another mystery we haven't even got time to go into at the moment. But effectively, these little tiny objects, they bounce off an object. So for instance, that red book over there, photons are bouncing off that and are going into my eye. Now the photons themselves are even more intriguing, because the same photon doesn't travel across that space. The photon, as it leaves that surface there, as it's reflecting off the lights here, actually the photons hit other atoms in the air. And as one photon hits an atom, the atom takes that photon in and then ejects another one. So the light that is leaving that is not the light that hits your eye. So even now there's a divorce between the physical object out there and what is hitting your eye. It then goes into your pupil, and it goes through what's called the aqueous humor. So again, the photons you think are the original photons keep getting changed all the time, and it gets to the back of your eye in the retina. The retina is inverted and postage stamp sized. And when the photons hit the signal is then converted into an electrical impulse, an electrochemical impulse, which goes down what's called the optic nerve, which crosses in a place called the optic chiasma. And if people who've seen my other talks before will know that I consider that significant, because the optic chiasma actually crosses directly below the pineal gland. And I think that's of significance, but we haven't got time to talk about that at the moment. Your visual cortex. And then, from that inverted postage stamp image, it creates this. That's magic. Where's it getting the information from? And more importantly, where's it getting the information from to fill in an area of your sight that you never do see, which is called the blind spot. At the back of both of your eyes, where the optic nerve leaves, is not light sensitive. There is a blind spot in both your eyes, but you never see it. I remember talking many years ago to an optician I went to, and I mentioned this to him, and he said, "Don't be stupid. That's absolute nonsense." He said, "The reason we don't see the blind spot is because we have stereo vision. And when the stereo vision comes together, it overlaps." And I turned around to him and said, "Oh, that's very intriguing. So what happens when I close one eye then?" And he turned around and he said, "Do you know, I'd never thought about that." It's what he was taught at university. And he wasn't thinking out of the box. He wasn't asking the big questions. He'd been taught it, therefore it was right. Which means that your brain fills in that little bit of information. Now, if your brain can fill in that little bit of missing information, why can't it fill in everything that's in your visual field? So in which case now we're starting to get into some really interesting areas of what takes place. Now, I was talking earlier on about the discoveries about the hallucination again. So to explain the near-death experience or out-of-body experiences or any other unusual experiences as just being hallucinations is just label theory, as I call it. It's the idea, give something you don't fully understand a nice grandiose name, preferably Latin or Greek. I call it idiopathic science, and if anybody knows their Latin, they know why I call it that. Idiopathic is a term that doctors use when they want to give you a diagnosis but they don't know what's caused it. Idiopathic epilepsy. I call this idiopathic science because it clearly is, we just give it a label. So for instance, if I see something that's not out there and not shared with somebody else, it's an hallucination. If two of us see the same thing, science has an answer for that as well. It's called a folie à deux. But the problem is, when you're using that as an explanation, Mr. Scientist, you've got a bit of a problem, because you're suggesting telepathic communication between two brains in order for them to share the same thing. So that's not an explanation. So what you're doing there is you're using one thing you don't like to explain something else you don't like even more, because your science can't explain it. So suddenly you see how my argument is, we're now like the medieval schoolmen, we're building these huge Heath Robinson science to explain things that we don't understand. And when a large group of people has a hallucination, like the people did, say, in Fatima in 1917 or wherever it was, they turned around, they saw the sun spin in the sky. Oh, it's just mass hallucination. Well, of course, yeah, of course it was. So there's no explanation here. But modern science is now digging deeper and deeper into this understanding, and there's a new generation of neurologists and neuroscientists that are just saying what the facts tell them, rather than what their training and their prejudices say you can't go to. For instance, Robin Carhart Harris has been doing a series of experiments with psilocybin, and they have volunteers who take psilocybin and they then scan the brain to see what happens when you take a hallucinogenic substance like psilocybin, magic mushrooms. Now, what they expected to find was that the brain breaks down. The brain, its ability to work properly starts getting denuded in one way or another, which means that the brain starts to confabulate information in one way or another. What they discovered was complete opposite. What happens is psilocybin switches off areas of the brain. It stops the brain doing what it actually is supposed to do, which is to act as an attenuator. As Henri Bergson argued in the 1890s, C.D. Broad argued, Aldous Huxley argued in 1954 in his Doors of Perception, the brain is there to take information out. When you take something like psilocybin, DMT, or all these other substances, it actually stops the brain's ability to act as an attenuator. It breaks down the brain's ability to cut out the information field. And this is why you perceive things that normally you can't see. It doesn't mean they're not there. It just means that your brain is stopping you doing it. But what they also discovered was that other parts of the brain start to communicate in a different way. They seem to communicate instantaneously. Now, this is intriguing, and I think I'm the only person that's been arguing this point. I believe, and if there are people listening to this, or there are scientists out there, please tell me I'm wrong on this. I believe that what is taking place here is we are misunderstanding how the brain functions. We are preoccupied with the neurons. We're preoccupied with neuronal communication, neurotransmitters within the brain that transfers information from one part of the brain to the other using chemical transfers within the synapses, with the release of certain chemicals. What I think is taking place is we are misunderstanding the brain. We believe that it's the neurons that causes consciousness. I believe it's something completely different. I believe it's something called the astroglial network. Have you heard the phrase, we only use 10% of our brains? This is because only 10% of the brain is neurons. The rest of the brain is glial cells. Now, the clue of glial cells is in the name. Glial means glue. And the glial cells, supposedly, when Kajon and various other people did their research, they could see the neurons, but they could see far more of these other cells, astroglials and various other things. And they said they're holding the neurons in shape. They're keeping the neurons in shape. But imagine a scenario that we've got it wrong. Imagine a scenario that, in fact, what is taking place in the brain is it's the astroglial network where the communications take place. Now, they've discovered certain things in recent years, something called the calcium wave, which is this incredible wave of information that goes across the brain. Now, could it be this is how the brain actually works and we're looking in the wrong area? And I'd argue, because this could explain one of the great mysteries of science. It's something called the binding problem. And you ever want a neurologist to start feeling awkward or nervous? Just mention the binding problem. The reason the binding problem is such a problem is that we have a feeling of simultaneity, don't we? Everything is happening now, at this moment. You're watching me moving around, trying not to fall asleep and that kind of thing, or making sure that nobody notices you're falling asleep. And you can see everything that's happening now. But using an analogy, a red bouncing ball going down the street in front of you. The red is being processed in one part of the brain, the bouncing movement is being processed in another part of the brain, and there's various other things in your visual field that are being processed in different parts of the brain. Plus the sound of the ball bouncing is in different parts of the brain. Yet we feel it's happening now. But the speed of transfer of information, considering that the different parts of the brain are relatively quite far away from each other. So there should be a time lapse between them in order for us to have the feeling of simultaneity. Because electrical signals within the electrochemical signals within the brain have a limited speed. They're not very fast. I don't know the figures, but it's something like 200 feet a minute or something. So we couldn't have that feeling. So either the brain buffers information, so it gets all the information like a computer does, and then it presents it to consciousness, or it's communicating in a completely different way. And I'd argue the astroglial network works non-locally. We know from quantum mechanics there is a thing called non-locality. The idea that if you put two subatomic particles in the same quantum state, and then you put them apart, whether they're 10 feet apart or 10 million miles, if you do one thing to one part of the other one reacts instantaneously. It's what Einstein called spooky action at a distance. Now, this is then intriguing, because it means our idea of what is space and what is time suddenly starts to get a bit strange now, doesn't it? Because if you've got two particles at vast distances from each other, how can they communicate instantaneously? And the answer is, if at a lower level of reality, they are the same particle. It's what somebody called David Bohm called the implicate and explicate orders. And there'll be books referencing David Bohm's work in here. But what I'm trying to do is to take all this information from all these areas and put it together and go, hey guys, thunk, that's what's going on. So you have the non-locality and you have the way particles react together. Now this is suggestive of the fact that reality is far stranger than we can ever imagine it being. Now remember I said that if particles are entangled or placed in the same quantum state, they are forever in communication. Well, at the first femtosecond of the Big Bang, every subatomic particle in the universe was in a point particle in the same quantum state. And 13.8 or whatever billion years ago, Big Bang took place. So maybe our own whole illusion of space is much more mysterious. The idea, is there really space? Is space just a hallucination in its own way? The idea that there's distance between things, because that helps us work within what I would call, or what Andrew Gallimore, the neuroscientist, calls this instantation. This kind of shared reality that we co-create is also very important. In quantum mechanics, you'll have heard something called the twin slit experiment. And the mystery, and I mentioned before about waves and particles. In effect, what seems to happen is that a subatomic particle, be it a photon, which is a piece of energy, or an electron, which is a piece of matter, they all have what's called a wave function. They're all waves. They're waving in something, but they're waves. But not only this, according to Max Born, who was one of my favourite pieces of obscure information, is Max Born, the scientist, was Olivia Newton-John's great-grandfather, which I find quite interesting. Country roads, etc. So he argued that this wave function is a mathematical function. It's not anything physical. It's mathematical. And if you read the writings now of modern physicists and cosmologists, Max Tegmark is somebody that comes to point here. Get hold of his book, Our Mathematical Universe, about how this works. But the idea is everything is mathematical. It's information. It's information we are processing. So when a particle turns from being a wave, which is a statistical wave, that a particle will be found there or there, because that's how it works. Basically, in quantum mechanics, the idea that a particle is in a particular place in space and time is because statistically it's more likely to be found there than it is there. And this is why things like quantum leaping happen, because it's statistically possible that a particle could be outside of a box altogether. And we know from quantum computing that's exactly what they use. So we got the idea then we have this wave function, and what then changes the wave, the statistical wave, into a point particle is the act of measurement. When it is measured, it becomes a point particle in space and time. Now, these little particles are tiny, but experiments have been done in recent years where large molecules, I'm talking about things like buckyballs, which have 60 atoms in them. They've done the same experiments, and these things come into existence when they are measured. But the question then is, what do we mean by measurement? If I take a ruler and say, oh look, that's a foot long, what's doing the measuring? The ruler isn't. I'm doing the measuring as a conscious person. It's the conscious person that's doing the measuring. So I'd argue, and a lot of people do argue, that it's consciousness that collapses the wave function. Now, if consciousness is collapsing the wave function and bringing subatomic particles and molecules and large molecules into existence by the act of observation, where does the universe come from? Where is that coming from? We are co-creating this. We are co-creating because we are all collectively collapsing the wave function, and we are overlapping in our perceptual fields, and they overlap, and this co-creates consensual reality. So suddenly near-death experiences now are starting to get a little bit stranger, aren't they? Suddenly when we talk about near-death experiences, what do we really mean? You know, and in the book I go into vast detail about the neurological correlates of it, but also what it's telling us about the true nature of reality. Near-death experiences are incredibly common. In the book, I do background into the anthropological studies that have been done worldwide on near-death experiences. And I've made some very interesting discoveries. One of the discoveries that I think is still extraordinary is there's a lady called Dorothy Ellen Counts, who was a Canadian anthropologist, I think in the 1980s. And she was doing anthropological research in New Britain, which is an island off New Guinea. And the people there, many of you will be aware, remember after the Second World War there were things called cargo cults that came up. And the cargo cults were, what happened was the American GIs were there, and the local people would see them talk into their phones or their intercoms or whatever, and a plane would appear and would be carrying goods. So, being human beings, they rationalised the circumstances of what was happening here. And they interpreted it as being that if you speak to the gods will deliver stuff for you. And they started to become cargo cults, you know, the idea of getting cargo. But the thing is that they have very different near-death experiences to what Westerners have. When they have a near-death experience, they go to a place where there's factories, where they're making things. So in other words, here people say, oh, you know, I had my near-death experience, went into this wonderful place, went to heaven, saw Jesus, saw all these wonderful things. That's cultural. Because these people turn around and say, they see factories, they see their friends working, making things. But there was one case that I thought was particularly intriguing. And it was a gentleman who had dropped dead, or had gone into a death-like situation. And he comes to, and he's in this place, and he's walking along this road, and he meets another lady who he only subsequently found out had died while he was dying. So he reported back, so he had veridical information of stuff he couldn't have known about. But then he walks along, and there's this beam that comes down and drags him up. And then he finds himself inside what he called was a house. And inside the house were these little beings. And the little beings started operating on him and started playing with him. Then he looks outside and realizes that the house is hovering. And then the beam then takes him back down, and he finds suddenly he's back recovering. That is a UFO abduction. There is no other possible interpretation you can have from that than it's a UFO abduction. But we also know that the same kind of scenarios take place when people take dimethyltryptamine. When they take dimethyltryptamine, they go into this alternate place, and there are these entities. And these entities not only know we're coming, they recognise us. As we know, there's research being done at the moment at Imperial College in London, where volunteers are actually taking DMT intravenously, and they are going into the DMT space where they are meeting entities, and they meet the same entities again when they go back in again. Now suddenly, I was talking about hallucinations and the idea that, well, a hallucination is something that you share on your own. Well, what's going on here then? Are these really just hallucinations? Or is it that what is happening is the DMT, like psilocybin, is cutting off areas of the brain? Now, very important point as we get towards the end here, and this is a very important one. One of the things they discovered was when they were doing the research using the monitoring, is that it seems that when you get to the point of death, the gamma activity is so intense, you go into a state called status epilepticus, which is continual seizure. Now, there's a very, very famous case that is cited in book after book after book on near-death experiences, based upon the experiences of Dr. Eben Alexander. And Eben Alexander was a neurosurgeon who had a particularly nasty form of viral meningitis. And he blacked out, and he found himself, how he described it was, he said that he was in what he called the mud world, where he comes to and he feels like he's in mud, and he's trying to climb out the mud. And he climbs out, and then he finds himself flying, and he finds himself on the wings of a huge butterfly. And sitting next to him on the butterfly is a young woman who has extraordinarily coloured eyes. And the young woman talks to him. He then comes back down again, and he finds himself waking up, and he explains to his parents that what he'd seen, and he mentions the young woman he'd seen, and his parents went really quiet. They told him that they'd never told him before, but he had a sister who had died before he was born, and the one thing that was noticeable about her was her extraordinary blue eyes. That was supposedly his sister. And that is intriguing, because again, that's veridical information he brought back from that state. But the interesting thing again is that when he was in that state, as far as the neurologists and the people working with him was, he was again in a state of status epilepticus. So he was in this state of having this huge epileptic seizure. Now, those of you who know that have read my previous books over the last 20 years will know I've been banging on and on and on about the links between temporal lobe epilepsy, out-of-body experiences, precognitions, déjà vu, all of these things. So here I have tangible evidence that there is a link between epileptic seizures. Because again, there is an argument to say that DMT and all these other drugs, they simulate epileptic seizures. Any of you are aware of the near-death experience history. There's a guy called Carl Janssen at the Maudsley Hospital, and he wrote a series of fascinating papers where he noticed similarities between people who are taking ketamine and near-death experiences. And he argued that whatever creates the near-death experience neurochemically within the brain is mimicking ketamine. Now I argue, no, it's not just mimicking it. I argue it's endogenous DMT itself. I argue that the human brain itself at the point of death releases DMT to create the near-death experience. That is why the near-death experience is so similar to DMT experiences and various other things, because it's DMT being synthesized by the pineal gland from melatonin into DMT. And melatonin and DMT are very similarly structured molecules. I think there is only two, I think there's a difference of 2 hydrogen atoms or less of 2 hydrogen atoms. So suddenly we've got a kind of neurochemical answer, but it's not answering where you go. All it means is that it's putting you in a different location. Now, this epileptic seizure, I'd just like to read something from my first book, Is There Life After Death? And it's to do with what happens when a baby is born. So remember, I've just said that we die in an epileptic seizure. Okay, this is what was said. If electrodes are attached to the stomach of a woman in late pregnancy, the brain waves of the fetus can be recorded. This is a quote, this is not my words. Usually these prove to be slow delta waves at a frequency of less than 3 cycles per second, but sometimes this regular pattern is interrupted by larger discharges, similar to the spiky recordings obtained from adults in an epileptic attack. As the baby approaches full term, these compulsions become more frequent until at birth they are almost continuous as the child thrashes its way into the world. We are all born in something like epilepsy. And if we survive the experience, it seems likely that this could be just the sort of positive conditioning necessary to produce the same response again in a later comparable crisis. I'd argue that later comparable crisis is death. And I'd like to finish with the final line that I say in this book. This is from 2006, and I wrote this in 1999 to 2000. In other words, we die in an epileptic fit and we are born in one. On that point, we may be reminded of the epileptic writer Edmund Goncourt, who described life as an epileptic fit between two nothings. In fact, this book has shown it to be nothing between two epileptic fits. Thank you.